Hi, my name is Christian Mena, and this is my R research presentation for my class in CIT 381. My presentation have divided it into 5 topics. I'm going to be explaining what is R, uh, how to download R, what is a package in R, how to download a package in R, and I'm going to be giving some examples of how to use R. So, what exactly is R? R is a free language and environment for statistical computing and graphics. R provides a wide variety of statistical analysis, like linear and nonlinear modeling, classical statistical tests, time series analysis, classification, clustering, visualization, etc., and graphical techniques, and is highly extensible. What it means to be highly extensible is that R is based on packages, and you can add packages according to your needs, or you can create your own packages. And as I was mentioning, that it's based on packages, is because the R is more than just a statistical package. It's a programming language, so you can create your own objects, functions, and also packages. How to download R? And here in this PowerPoint presentation, I have provided with the link for the official um, R website, and in a little bit I'm going to be showing how to download R and how the website looks like. Now, it is important that when you download R, you also download, well, you don't have to, but it's useful in case if you want to do some programming to download a code editor. I'm going to be showing how to download the R Studio code editor for Windows and R. And like I said, that R is based on packages. But what is a package in R? A package are a collection of R functions, data, and compiled code in a well-defined format. The directory where packages are stored is it's called the library. R comes with a standard set of packages. Other are available for download and installation. Once installed, they have to be loaded into the session to be used. And here I have provided the link for the current packages in R available to download, and I'm gonna show uh, the website in a little bit as well. And to finish this presentation, I'm gonna give a couple of examples, a few examples how to use R. Okay, so I'm gonna change my screen so I can continue my presentation. So this is the R uh, official website. Here is where you can download R, and it gives you a couple of options depending of your platform. In my case, I downloaded R for Windows. So if we click here, since it was my first time using R, I chose the first one here where it says install R for the first time. If you click there, here we'll provide it with the latest version of R, which is the 3.3.3 version for Windows. And if you click here, it will give you the steps to follow in order to download R. One of the things that I mentioned also, it was to something useful to download. It was a code editor that interfaces with R in Windows. In this case, I'm going to be using R Studio. There's other options for Microsoft and other options too, but I'm going to be using this one. So the R Studio, this is the official website. Here you go to the download section, and then it will give you 4 options, 2 free options and 2 um, commercial license if you want to buy them. In my case, I download the R Studio desktop because I wanted to have it on my computer, and I download it here. And then again, you just follow the step, which are pretty straightforward and simple. Another thing that I mentioned in the PowerPoint, the previous PowerPoint presentation, was the packages that are available for R. This is the how the link for those packages look like. And as you can see, the list of packages were quite extensive. And, and this will give you the flexibility to use R according to your needs. Um, just for you to have an idea of what kind of packages are available, let's pick just one. And here the DDR package is it, the distributed data structures in R. Then there's another one that says data driven smooth tests. Um, there's another one that you can use to import or export data into a link or website. In my case, I'm going to give an example of a package called ggplot2 that is for visualization in R. But I'm going to get into more detail in just a little bit. So, once you have downloaded R and the R Studio, this is how it will look like. And I'm going to be giving some examples of these R. The first one is how to download a package in R. And here you will use the command install. Sorry, let's spell it, install packages. And as I mentioned before, I'm going to be downloading the ggplot2 package in R. Once you have entered the command, you hit enter. It will download it automatically into your console. Since I already did it, I'm not going to be pressing enter. But one of the things that I mentioned when you use packages is that you have to load it into your workspace. Excuse me. So in order to use this, you use the command library ggplot2 and you hit enter, and then your package is ready to be used um, in R Studio in this case. Um, so I'm going to be explaining a little bit of basic functions that you can use in R. To my way of thinking, to visualize how powerful is R, I'll take it that it is a supercharged booster Excel software kind of thing, where you can use this super powerful scientific calculator that you can do many things and many other stuff, cool stuff. So for example, I'm gonna create a variable called x, and I'm gonna assign the value of 11. And then I'm gonna create another variable called y. I'm gonna assign the value of 7. Now those are stored. If you can see here, oh, by the way, these are our studio. Here in the left hand, upper left hand, this is the code editor. This is the right below is the console where you write your commands, and the right upper hand is your environment, which you will see values that I have just created, the objects value, and you can also see your database, the data set that you import. And here down below, you can have some options like viewer, help for studio, packages that comes with R. And in this case, right here is the ggplot that I just downloaded, and some plots like graphics. So to follow this example about some of the things that you can do in R, for example, you can add these values like x plus y. That will give you an option. You can also use let's say a calculator like 125 times 7,845. That will be the answer. Now, in the case that I created the objects x and y, uh, if I have a bigger list of objects, I can use the command ls to see the list of objects that they created. In this case, I have only two x and y because those are the examples I created, but it's a very useful command in case if you have a bigger list of objects. In the case if you wanted to remove an object, you use the command rm and then the name of the object. In this case, I'm going to erase y. And then if you try to call it, it'll give you an error because I just removed it from the list. Another cool thing is to import data. So let's go back. The command that I'm going to be using for that. And something important to know when importing data into R is that you need to save the file as a CSV file or text file in order to import this the data into R. In this case, I'm going to use the data that I'm using for the game theory project, rock, papers, and scissors. I'm going to use, sorry, I'm taking it along with this. Where is it? Use a name. So I'm going to store the data that I want to import into a name called data game. So I'm going to use the command read.csv. Then I'm going to use the command file choose. This, for me, this was the easiest way to access to a data set that I have in store because it will open a window and you can just go directly and choose the file that you want to import. There's another conventional way that you need to write the path in which you have storage for data. This one is the simplest one that I found. Then you use the command header. And in this case, I'm using true because the data I want to import, it has some header in the data file. And in case if you don't have any headers, you just false. And as I mentioned before, it will open this window. Then I'm going to choose my data, game data. And here, I just imported my data into RStudio. So if I click here, then it will show me the data that I just imported. In this case, I have the number of plays, the moves that I made playing with my son Carlos, and all the data. Okay. Now I'm gonna be giving some examples of linear regression. In order to do this, I'm gonna be using a data set that comes with the standard package in R, and I'm gonna be using the data set air quality. So I'm gonna, and first of all, I wanna see what kind of names comes into this data set. I'm gonna use the command names, and then I'm gonna call the data set as air quality, and you will see we have 1, 2, 3, 4, 5, 6 different data sets. One is for ozone, solar radiation, wind, temperature, month, and day. So the first thing I'm going to do, I'm going to plot some of these values. And I'm going to use this command. The command I'm going to be using is plot in parentheses. I'm going to use ozone and solar radiation. And it's important to mention that you're going to be using data name air quality, so the R can know which data set they're going to be using. So then press enter. And here I have in my right hand, I have my plot. So something important to mention that when you're plotting the data, the first value here in this case is ozone, Y value, The second one is your X, which is the solar radiation. So we have graphic solar radiation in function of the ozone. As you can see, as more solar radiation we have, um, bigger is the concentration, more spread is the concentration of ozone. Okay, now I'm going to be adding a line into this so in order to make a model. So but first of all, I'm going to create a model for my linear regression, and I'm going to call it model one, and this is the name I'm going to assign my linear model. So I'm going to use model one that's the name of the variable of the object in this case. Linear model using the zone solar radiation on the data set of air quality. I did enter. So I just created the model. Now I'm gonna add a line into it. I'm gonna use the command AB line, model one, and assign a color and red for the line. I just created a linear regression for my modeling. Oh, something important to notice in this, if I call the model, will give me some important information. In this case, the intercept of the y. If you think of um, the uh, the uh, the line of regression, this is the y-intercept value, which is 18.5987, and the 0.1272. This is um, the slope, of the line. Okay, and now we can also have a summary of this model. And we'll provide more insights with the coefficients estimated, the standard error, the t-value, and they will give you more information about the p-value is here too, the f statistic value. So like I said, this is positive, strong um, data set. As you can see the line going up. When it goes up, it means that it's positive. And since the data set is close to the line, it means that it's a strong data set. If it was more spread, it will be weaker, and the opposite inclination, it will be negative. Okay. So this is an example of a linear regression that you can do in R. Like I said, I'm going to be explaining also visualization in R as part of my presentation, and I'm going to be using the package GG plot2, which already downloaded into my workspace, and I already called this library. As you can go up right here. I use the library ggplot2 to call this function. So I'm gonna start using it. So I can give my example. For in this case, I'm gonna use another data set that comes with with uh, with R. I guess it just did that by itself. I'm not gonna be using the air quality. I'm gonna be using the package miles per gallon. There you go. This one. So here I have a data set that is according to models, the years, the cylinders, the transmission, if it's four-wheel drive, the mileage per gallon on the highway, if it's what kind of car is it, is a compact or not, things like that. Okay, so I'm gonna plot this information, and I'm gonna, in this case, to plot this one, since I'm gonna use the package ggplot, I'm gonna use the command q plot, then display command, use highway, and the data in miles per gallon, and I'm gonna assign some color to it. That's it. There you go. So in this case, I have, display the highway for cars that have four-wheel drive, front-wheel drive, and rear-wheel drive, um, and assign the colors. And this is something that this package does automatically. It assigns the color by itself. I think you can assign the colors if you want to. You can change the set points, but in this case, it did it by itself, and it's a professional way to do it. Um, Depending on the values they have, it shows the color red for four-wheel drive cars, the color green for front-wheel drives, and the color blue for rear-wheel drives. You can also let's do a summary. Uh, for this data set, and will show you a lot of information about the models, the number of models that you have, the years, the city, the transmission, the cylinders, the highways, all this type of data that it comes in this data set. Another thing that I'm gonna be yeah, graphic another plot here. There's the command plot, use display and highway again in the data column, and there's another command that is called geom, and point and smooth. Okay, so here is a statistical analysis. Uh, so the geom is a sum of summary of the data. That's what I'm doing right now with this plotting, this plot, using the same values of the highway and display. You can see this statistical analysis, the summary of it, where it draws a line close to the data, and just another visualization that we can get in this powerful tool of R. And I'm gonna show my last visualization example that you can do in R, and this will be a histogram using the same data, the mileage per gallon. So I'm gonna call the function qplot, and again, I'm gonna use the data set highway and the data mileage per gallon. And I'm gonna use the command fill equals histogram. So this command, the geom, helped me to do this histogram, which again it chose the colors automatically. And in this case, excuse me, the representation of the colors uh, says that the four-wheel drive tend to have a lowest mileage, um, and in the case of the front-wheel drive, tend to have highest mileage. So you can see the four-wheel drive is in this pinkish color that we can see, and the front-wheel drive that is green has this graphic. So we can see that the front-wheel drive tend to have a highest mileage. You can see this is the X value that we put our highway mileage right here. That we can see it has higher mileage than the four-wheel drive. Okay, and that's it. That's my presentation for the R Studio. I mean the R package. It's a very powerful tool for statistical that some of the examples that wasn't able to recreate um, because they're very advanced and use very more complicated functions and coding. Uh, but it's very amazing. One of the things that you can do with this R and all the analysis that you can do so simply. It's all in so few lines. All the things that you can do. For example, in just in one line, I created this histogram, and another line I created this plot with this statistical analysis, the summary of this, some summary of the data, and this plotting, professional plotting uh, for data set. Um, so I hope you enjoy it and was useful. Thank you.